Hello and welcome. I'm Chris Nickel, Natural Science Professor at St. Petersburg College. The aim of my presentation today is to teach you about beach zonation, and then look at the impact of storms on our coastal ecosystem. Our coastal ecosystems are basically a barrier island system. Barrier islands were formed at the end of the last ice age, and they're giant sandbars that go down the coast of the Atlantic and around the Gulf Coast. The Pacific Ocean does not have barrier island ecosystems, but the eastern seaboard, that's the main coastal ecosystem formed by the deposition of sediments at the end of the last ice age. If you look at this illustration, you can see that they are broken into zones. When you're looking at the Atlantic or the Gulf, you have your offshore, and then onshore you have your beach, which we will be talking about. And the beaches run from the water's edge to the dunes. Dunes are built up by sea breeze and vegetation. Behind them you have grassland in this illustration and scrub thicket. Then we have the maritime forest. Behind that you have flats, mangroves in Florida, salt marsh in Florida as well. When you go up a little North Florida and beyond, it's all salt marsh because mangrove is a tropical with some subtropical species possible. And then you have the intracoastal waterways. Waves carve the shoreline. They generally deposit longshore bars, slightly raised because the waves erode the beach and then redeposit in the surf zone. The surf zone is where the waves break. Waves break at a depth of half of their wavelength. So what happens is when the wave breaks, it erodes the beach and deposits it in sandbars. That's basically, on a grand scale, how the barrier islands form. But the surf zone is the first coastal ecosystem. It's the area where the waves break. You can see this image is from Fort DeSoto, and it is a longshore bar that was deposited after a storm. They can be quite sizable. In this case, a jogger and a bunch of birds are using it. We use them as recreational a lot. People anchor, uh, drink iced tea, play frisbee, uh, and hang out on these shallow areas. They also can break the surface in this case. Behind the beaches, there's scrub zones. This image is a saltern. It's a hypersaline area in the scrub zone. It's a little depression where the water builds up, evaporates, salt builds up, so it's hypersaline, more salt. Uh, they're formed during storms. Water sloshes back further than it generally does, and then when it evaporates, it leaves very salty environments. If you have a depression, they can build up over years and become hypersaline. They slow down plant growth. Uh, trees can't grow there because it's too salty. Very salt tolerant plants are the only things that live there. Cord grasses, which are salt marsh plants. You see a lot of seaside purslane, very salt tolerant plant, but you don't get large trees in this ecosystem. And they are fed more salt water during storms. The crown of that barrier island, if you picture it as a bowl upside down, the absolute top of that bowl tends to be a little flattened. and trees grow there. They have to be salt tolerant because you get a lot of sea breeze and you do have salt influence, especially during storms. But you do have what we call a maritime forest, or a forest influenced by the ocean. Uh, the image there shows you live oaks. So we got live oaks, slash pines, cedar, intermixed with scrub vegetation in the understory. So the mature ecosystem of the barrier island is the maritime forest. In Florida, where we have a subtropical climate, where the barrier island meets the intracoastals, we tend to have mangrove habitats. Mangroves are a group of unrelated trees, and they can actively remove salt. Uh, they generally grow red to black to white. If you go in the water, red have prop roots. Black mangroves have pneumatophores, and then white mangroves grow behind them. Uh, the buttonwood, which is associated with mangroves, it's not a true mangrove because it does not actively eliminate salt, but they are found in generally all of our mangrove habitats here in Florida. They grow interspersed with the white mangroves generally a little further back. Now, there's other species of mangroves that grow in more tropical climates, but we get the red, black, and white here in Florida. You can see here is a red mangrove, and I mentioned the prop roots. They grow furthest out into the water, and these prop roots help anchor the substrate or sediment. Uh, they actually come from branches, so they can grow out and actually add area to an island or a coastal ecosystem. Native Americans that lived in Florida called them walking trees because of this. You can see they have the prop roots uh, that help them anchor the soil. They're very, very important when it comes to storms and flooding because they fight erosion and help fight storm surge. The second type of Florida mangrove are the black mangroves. Black mangroves actively remove salt through their leaves. So their leaves can be uh, silver on the backside, and they have grains of salt on the surface. They have special roots. You can see those pneumatophores, and they help them in anoxic soil, soil that's waterlogged and is low in oxygen. Our third type of mangrove is the white mangrove. These structures shown on the base of the white mangrove's petioles are called nectaries. They actively regulate salt and sugar balance. They do not have a visible root system like the other two types of mangrove that we discussed, but their special adaptation is the ability to regulate salt and sugar balance using these nectaries. They grow the furthest back, but they're the most salt tolerant because of that evaporation. Uh, they can tolerate salt the best out of all three mangroves. We mentioned the buttonwoods, and we have question mark there, meaning are they really mangroves? It's been debated back and forth, but consensus is they're associates of the mangroves, not true mangroves. Although they're found interspersed with the mangroves, they do not actively regulate salt balance. They're just hardy and salt tolerant. You can see the little buttons there on the right-hand picture, and that's how they got their identification as buttonwood. In an area slightly beyond the mangroves, or between mangrove stands, or after a storm, if the dunes get leveled, or if mangroves get replaced, we have salt marshes. Salt marshes are made of a hardy cordgrass belonging to the genus Spartina. There's two types. There's smooth cordgrass, or Spartina alterniflora, and there's marsh hay, Spartina potens. Generally, there's other plants mixed in, saltwort and uh, seaside purslane are common. On super low tides, mud is exposed, and that's what we call a mud flat. So salt marshes are made of cordgrasses and other plants. Mud flats are only visible during the lowest tides. They're home to many mollusks like clams that can burrow into the soft mud. During low tide, birds love to walk around on mud flats and eat these mollusks. So salt marshes and mud flats are more tolerant, more cold tolerant than the mangroves. When you go above the when you go above the freeze line and you get areas that freeze, the coastal ecosystems are dominated by salt marsh. Uh, Below that, where it doesn't freeze, the coastal ecosystems are dominated by mangroves. I mentioned the value of mangroves. Uh, they help hold the soil in place. They help grow out islands. They block storm surge. Salt marshes, because they're very rich in plants, and these plants need nutrients, they're good at wastewater treatment. So we use them. For sewage treatment and wastewater treatment because they absorb pollution. They also help hold that soil in place, their roots, so they're good against erosion. Now, the estuaries, which is where salt and fresh water meet, mangroves considered an estuary because it's touching the land and we get fresh water. Salt marshes are considered an estuary because there's fresh water input as well. These are very important ecologically because they're the nurseries of the ocean organisms. Uh, they're a little safer habitats, more nutrient rich than open ocean. So many, if not most, marine organisms come to the estuaries for reproduction. We mentioned the dominant grasses in salt marshes are the Spartina. This is the smooth cordgrass, or the most common of the salt marsh grasses. It grows very tall, and it's at the lead edge of your salt marsh. Uh, Closer you get to the water, the more Spartina there is, and the taller it gets because it gets more nutrients from that tidal inflow. The back of the marsh tends to have smaller plants and more diverse plants because they get less tidal input. Now, the intracoastals are the water found between your barrier islands and mainland. So they are estuaries because they get fresh water input from the mainland, salt water input from the Gulf or the Atlantic, and they're the cradles of the ocean. That's where the organisms come to reproduce. They're very, very diverse. They're important ecologically, not only for food, recreation, and storm abatement, reproductive areas. So they're very, very important habitats. In these intercoastals, you find a variety of seagrasses. Shoal grass is the small, most shallow growing of the seagrasses. Manatee grass is a little longer, wiry, very cylindrical. You can spin it in your hand. And then the turtle grass is a thick blade that grows. These are very, very diverse habitats. They support a thriving seagrass populations, sea turtles. The green turtle eats them. Manatees eat the seagrass. So they're very important shallow water ecosystems. They are prone to sedimentation, and they're prone to, as you can see here, uh, boats. Prop scars take years to heal because it's not like turf grass on your lawn. It's they have underground stems, and if you cut them, that area dies and won't grow back as quick. Now, I just summarized barrier islands for you. Now we're going to take a close look at beach. Beaches are zoned. I mentioned the surf zone early in the introduction. That's where the waves break and erode the sand. They also deposit sand in those sandbars, longshore bars. The forebeach is right at the water's edge. It's tightly packed. It's wet. Uh, it has a incline up to, usually you get a rack or a debris line. Okay, that's where the highest of the tides hit. And a lot of times after storm, you have a line of seaweed that has washed up, or a line of debris, and that's called the rack line. Behind that, you have the back beach, which is sand, but that sand is never really underwater unless you have a storm surge. This is where you'd throw your towel and it would not get wet. Behind that, you have your dunes. So the back beach transitions into the dunes. The dunes are piles of sand that have been pushed there by sea breeze, and plants grow there. The most uh, important plant of the dunes are sea oats. Sea oats and other plants hold that sand in place. Now we're going to go through beach zonation. This is a picture of the back beach there at Fort DeSoto. It's a very wide beach in this particular area. Habitat to a lot of terns, gulls, skimmers. A lot of birds wander this beach foraging for food. There are beach nesting birds. Now, beach nesting birds conflict with beach goers, and usually the beach nesting birds lose. So we cordon off areas of beach and try to keep people from going there, uh, so the birds have places to nest. The first zone of the beach are where waves break, and this is called the surf zone. Here's a picture of a surf zone here. You can see that wave breaking. Waves break at half of their wavelength. So the stronger, longer waves would break farther outshore. That's why we don't get tsunamis here in Florida. Well, we're not on a tectonically active background or fault line anyway, but waves break. So if you have shallow water, you have little waves. If you have deep water, you have big waves. But that surf zone is what erodes your beach, pulls it back, and deposits it into longshore bars. Right on the edge of the water, you have forebeach. It's wet. You can see that sand is wet, it's tightly packed. You have ruddy turnstones. Those are some oyster catchers in the middle. They are beach nesters, and they're a little bit rare. Skimmers. Uh, the skimmers fly with their beaks and just dip into the water and catch small fish. Sandpipers and turnstones forage in the sand for crustaceans and mollusks. So you have a uh, small ecosystem of birds, sandworms, mollusks like coquina grow on the forebeach and spend their lives there. So it's a thriving habitat, the forebeach. Generally, you find a debris line behind the forebeach. We call that rack. It can be seagrasses that have been ripped up, algae that has been washed up, shells build up there. Uh, a lot of birds forage this area. You get insects coming there because, this plant material is starting to rot. It provides food and cover, places to lay eggs. So you get that rack. Sometimes it gets a little smelly after storms. It piles up. We call that the rack line. Behind that rack line, you have that dry area we refer to as the back beach. You can see in the image the sea turtle. Here in Florida, we have the loggerhead turtle nest in this particular area because it's not going to get inundated with water unless there's a huge storm surge. So this sand stays dry. The image on the right is some seaside purslane that's toward the back end of the back beach, and that's transitioning into dune. Uh, Piles of sand will grow, build up in this particular area, and then transition into the next zone. Speaking of the dunes, here's a few images of the dunes. Sea oats are the most important dune plant in our area. We also get the seaside sunflowers. You get some salt marsh grasses mixed in, but they usually get outcompeted. You get seaside purslane, railroad vine. So you get a variety of plants holding that in place. It becomes habitat for a variety of animals as well. Now, these images were taken before major storms. You can see the dunes look stable on the right. You have those sea oats holding them in place. You have a very wide forebeach. In the center, they have removed a lot of that dune area for hotels and condos. And that's all well and good until you get hit with storm surge and you don't have those dunes to block storm surge. The image on the left, you see a lot of the saw palmettos. They grow back behind the dunes or toward the back end of the dunes, behind the dunes in that scrub area, and they also help reinforce the coastline. Just a little bit of wildlife. On the left, you have the fiddler crab, and they are found all along both the back of the beach and in those intercoastal muddy areas, sediment behind the mangroves. They dig holes down just below the water table so they can get water and land. Uh, I found the other picture to be interesting. Skimmer, that's a black skimmer, and it's laying on the forebeach. Uh, I'm not sure why they have this behavior, but sometimes skimmers take a little rest on the beach. Now, we've talked a little bit about beach erosion, especially with waves, and the prevailing winds create prevailing waves, and those waves push in a direction, and that's called longshore current. So beaches are eroded by waves that cause longshore current, and they push the sand in that general direction. Swimmers can get pushed by longshore current as well. So the beaches are eroded directionally by longshore currents. We call that directional erosion longshore transport. So our longshore currents push the beach in a direction, and that's called transport. Another current that affects our beaches are rip currents. These waves are coming in, and when you go to the beach, you don't see huge piles of water. So the water has a return flow, and that return flow is called a rip. Gentle wind, small waves, weak rip current. Strong storm, big waves, strong rip current. And rip currents are very dangerous currents to beachgoers. But a rip current is formed by the return flow of waves. Here's a list of videos that I have on a YouTube page that I run. And this is off of a playlist that is coincides with this program. The link is given below, and the videos that I took were on Madeira Beach and Fort DeSoto. going through the general structure of a beach. So at this time, if you are watching this at home or as part of an assignment, you should stop the video and watch these video field trip shorts. When I opened up this program, I mentioned we're going to discuss storms. Of course, in Florida, they have a huge impact on our coastal ecosystem, but they really have impacts around the world. We will focus on our local storms, and you can see here are storm tracks around the world. A cyclone is considered a low pressure system. It's called a cyclone. And hurricanes are low pressure systems that form over a body of warm water, and they move very slowly along these equatorial currents because it's warm water being moved by the trade winds toward, well, if they form in the Atlantic, they move toward the Americas and toward Florida. You can see that they curve upward, and that curve upward is following the equatorial current curve into the Gulf Stream or the loop current, which is the current in the Gulf. Now, as a hurricane forms, it is a low pressure system. Low pressure is the rising air, and you get rotation because Earth is turning. Now, that rotation is caused by what we call the Coriolis effect. So you have a small wave of low pressure which can form a depression. Now, if it's over warm water and it's rising, it's moist, warm air, and it's warm, rising, heat rises, and that pressure gets lower and lower. So you can move from a depression to a tropical storm, as long as you're over the warm water still, to a hurricane. So these low pressure systems become stronger over rising air, and they are more violent because they are over water, warm water. It forms, land storms form similarly over warm land, but they don't carry the moisture and grow to the sizes of hurricanes. And that's because of the warm water. Now, when a hurricane makes landfall, it's pulling what we call a storm surge. We'll get to what a storm surge is in a minute. On land, we have regular rises and falls of sea level before even you add a storm surge to it. And that is called by the tides. It's caused by the tides. Tides are a bulge of water, primarily caused by the gravity of the moon, but the sun does play a role. So when the sun and the moon are at a right angle, like at a neap tide, you have a more moderate tidal surge. On a full moon or a new moon, when the sun and the moon are lined up, you have strong tidal surge. Now, during a full moon or a new moon, you can have 3, 4, even 5 feet of tidal surge. If you add that to a hurricane storm surge, you are getting an astronomical sea level change. Now, a neap tide tends to be moderate, a lot less, and if a hurricane were to hit during a new moon, then its impact would be less as far as coastal flooding goes. So we have this low pressure system. Low pressure system is rising air, and it's pulling up water. So you have a hump of water underneath that low pressure system. So we talked about tides, rising tide, and a hump of water. That's addition. So if you have a 5-foot storm surge and a 3-foot tide, you're going to have 8 feet of water make landfall. So tides are very important when it comes to hurricanes as far as coastal flooding goes. Again, if you have a low tide of -2 feet and a 5-foot storm surge, you're going to wind up with a 3-foot wall of water hitting the coast, which would be far better than an 8-foot. So when we add tide and surge, we get the total amount of water, and that's called storm tide. So storm tide is the total amount of water that hits our coastal villages, towns, and it's the tide plus storm surge. Now, these storms reshape our coastal habitats. They knock buildings and destroy towns. We witnessed that firsthand. They create passes like hurricanes pass. They erode beaches. They wash sand for 3-4 feet high inland. So they put a lot of pressure on our coastal ecosystems and cause a lot of change. Post-storm, the recovery of an ecosystem is called secondary succession. Now, in ecology, we call succession the natural change of an ecosystem over time. Primary succession comes from a barren ecosystem starting from scratch. Secondary succession is the recovery of a damaged ecosystem. A lot of times, a forest fire would force secondary succession. There's already a few things there, and we grow from there. Humans log or abandon areas that were once developed, and that would be secondary succession. We have a lot of secondary succession on our beaches and coastal ecosystems here because those storms moved in with the storm surge. They washed away the dunes, they covered everything with sand, and then when the storms are over, the recovery process begins, and we call that secondary succession. So wildlife is also distributed by these storms. A couple of years back, we had a tropical storm blow in some flamingos, and I was lucky enough to see these flamingos. We had one at Honeymoon Island, and this one was taken at Fort DeSoto, East Beach. So wildlife can be displaced and wind up in new habitats. It is theorized that the Galapagos Islands, the marine iguanas, and a lot of the life came from South America on storms. But we know we get a distribution of wildlife every time storms come, especially the strong ones. We find northern gannet and other seabirds blown into our habitat, and in this case, we had flamingos. On the lower right-hand portion of the slide, you see a tidal creek, and this did not exist pre-hurricane. But that is a whole new habitat, and it's full of fish and wildlife. And it is disappearing. I just went back last week, and it is shrunk in size considerably. So some of these habitats and some of these wildlife are just here temporarily. Here's a couple images post-storm that a friend of mine shared with me. You can see the flooding. That full barrier island is covered in water, and our beaches have been washed away. You can see how the dunes can survive because of those plant roots. But all that other beach has been washed away, and it was all the sand was covering these barrier islands and causing a lot of property destruction. These images were taken from Fort DeSoto. You can see on the right, that is that tidal creek that did not exist. That was all beach and dune area, but now it's flat. You can see salt marsh replacing what used to be dune because of succession. It's healing. That water is going to drain. The sea breezes will blow sand. That salt marsh will trap the sand. It'll grow, and be replaced by sea oats. You can see I walked on the lower left-hand image that Nhinga with his wings spread. You can see all the mangrove that were killed during the storm, and those are the prop roots that are left. So the mangrove and the dune ecosystem were flattened, and now they're recovering by secondary succession. Here's an aerial photo of Hurricane Pass, and this was carved by a hurricane. So it can cut a hole in a barrier island. And that's basically what a pass is. So these hurricanes can reshape our environment, and then secondary succession will take that new environment and mature and shaping it into a new habitat. Now, this is a kind of a cool image from Clearwater. I used to go on a lot of field trips with the Marine Aquarium, and we would stop off at a place called Compass Key. Compass Key is a small island that is across from the Coast Guard. And it's called Compass Key because they used to set their compass headings by that location using the key. It had one tree on it. It's been renamed One Tree Key, by the way. Of course, that tree is an Australian pine. Tropical Storm Sandy uh, blew that pine down. Then it was no tree key. But you can see how it reshaped that ecosystem. The Australian pine was a commonly imported ornamental, which is an exotic. It has a very shallow root system, so it really doesn't do well in storms. And you can see it did not do well during this storm. So it's considered an exotic invasive, although humans brought them in and planted them all around the beaches because they grow fast and they look nice and they don't take any maintenance, they fall down a lot. So how do we respond to these coastal processes? Well, we build groins, we build seawalls, we build jetties, and we have to re-nourish the beaches after storms. So that's why beaches are a $1 billion investment on our part. Over the years, it takes uh, a lot of money and a lot of labor to fight erosion, storm surge, and other problems. I'd like to wrap up this presentation by inviting you to watch some video taken at Honeymoon Island and Fort DeSoto post major storms. So we get to look at flamingos and the tidal creek, some of the changes in tide pools, flattened dunes, new salt marsh where it used to be dune. So below is the playlist uh, associated with post-storm habitat in Florida. Thank you so much for your time. I've enjoyed presenting this to you, and I hope you've enjoyed watching it.